Now that we've talked about the law of conservation of matter and how matter cannot be created or destroyed, we need to talk about chemical equations. Okay, and chemical equation is the symbolized version of a chemical reaction. So basically taking a reaction that's either written in words or things like that and putting it into numbers and symbols. And in a chemical reaction, the reactants are listed on the left side and the products are on the right side. And they're separated by an arrow. Okay, so for example, if you have hydrogen plus oxygen, it will produce water. And on the left side, we have our reactants, which is similar to a ingredient or things along that nature. And we have our products here. To take it into something that you might be more familiar with, if you have apples plus spices plus crust, you can make a apple pie. And so our product is the apple pie, and our ingredients or our reactants are the apples, the spices, and the crust. And it's important to know that each reactant is separated by a plus sign. Okay, and so we see that here. So just to go through the symbols and kind of what things mean, the arrow means to produce or yield. And so if you ever see that something is produced or these things were mixed together and they yielded X number of product, it's saying it's what is separating the reactants from the products. The plus sign means the same thing as it does in math class. It means to add or and. So you could say hydrogen and oxygen produce water, or you could say hydrogen and oxygen were added together to produce water. Either would be appropriate. An S in parentheses means that it is in the solid phase. L is liquid. G is gas. And AQ is aqueous or aqueous, depending on your pronunciation. And just as a critical reminder that aqueous means to be dissolved in water. So that means you have a solid that has been dissolved in some water. This triangle here means heat. So if you ever see a reaction that has an arrow with heat over it, it means in order for the reaction to happen, heat had to occur. This down arrow means a precipitate product. Now remember, a precipitate is when two liquids produce a solid. So that solid was not there before. It's a new thing that's been created. An up arrow means a gaseous product, meaning it's pointed up because gas escapes into the air in the upward direction. And then a double arrow means that it's a reversible reaction, and we'll get more into that in a later unit, but it just means that the reaction can go both ways. And when we think about signs of a chemical reaction, things that we've seen occur, we know that if we see bubbles form, that means that a gas has been formed, and that would be an indicator of a chemical reaction. We know that if we have a funny odor, for example, when something is burning, we see or we can smell the smoke and things of that nature. So we have bubbles, odor, a change in temperature that's unexpected. So, just because you put something on the stove and you heat it up doesn't mean it's a chemical reaction. Okay, it has to be an unexpected change in temperature, whether it's either cooling down or heating up. So with change in temperature, you can also have a precipitate, which is when a solid is formed. So anytime you have either a gas or solid or things like that. And then the last change is a color change, is an indicator. So if you have two things that are clear that produce something that's yellow, or you have any sort of color change, that would be an indicator of a chemical reaction. Now, just some quick things about balancing equations. Why do we balance equations? Because they have to obey the law of conservation of mass. You can't have atoms just come out of nowhere or completely disappear. And how do we balance them? We change the coefficients. That's the only thing you can change. You can never change a subscript, okay? And the important thing about coefficients is that they indicate the number of atoms, molecules, or formula units that are present, okay? And you can never change those subscripts, okay? If we don't have a subscript or we don't have a coefficient, remember, that means there's only one, because chemists, we know, are really lazy. We never write ones, okay? So just as a review, if you were to have the molecule that kind of looks like this, okay, we have magnesium phosphate. The 6 here would be the coefficient. It's out in front, and it tells me that I have 6 Mg3PO4, 6 magnesium phosphate atoms, whereas all of these are subscripts, and they tell me about the individual atoms in that molecule. So to go into further detail about that, if I were to write, kind of separate this out, I would have Mg3PO4. Okay, that's 1. I would write this 6 times. That's what that coefficient is telling me, that I have 6 of this whole thing, and that within one of these, those subscripts tell me how many are in an individual one. And so we see that if I write this out 6 times, 1, 2, 3, 4, 5, 6 times, I can add up all of my subscripts. 3 plus 3 is 6, plus 3 more is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, right? And I get 18 magnesiums, okay? But we also do the same thing when we multiply 6 times 3 to give me 18 magnesiums. And then 6 times P, and this 2 also gets multiplied. Okay, if you need a refresher on how to count atoms and things like that, go back to the counting atoms video so that you can check that out. But let's go ahead and erase all of this doodling here, and we'll get into the meat and potatoes of this video and what we really need to learn today. Okay, so the main thing that we know is that atoms are not created or destroyed in a chemical reaction. Okay, and the law that tells us that is the law of conservation of matter. And you might see this written as the law of conservation of mass. That means the same thing. So essentially, if you have sodium hydroxide plus hydrochloric acid and you're producing salt and water, okay, if I have 25 grams of this and 18 grams of this, then my total on this side of the reaction, and actually let's just make this a nice little even number here to make our math a little easier. 25 plus 15 would give us 40 grams total. And so because of the law of conservation of mass, this side weighs 40 grams and this water is 20 grams, then what would be my sodium? Well, it would have to be 40 minus 20 would give me 20 because these sides have to equal each other, which is why mass is conserved, but matter is also conserved because the number of atoms have to be the same. And so if we look back at our notes, scientists must know there must be the same number of atoms on each side of the arrow, okay, or of the reaction. And to balance the equation, you have to add our coefficients that we were talking about earlier, in front of the chemical formulas in the equation. You cannot add or change the subscripts, okay? Never, ever, ever can you do those things. So let's go through the basics of balancing this chemical equation. So if we look here, we have magnesium and oxygen produce magnesium oxide. And so according to our first step, you have to determine the number of each element. So basically count it up. Anytime you don't see a subscript, that means we have 1. So I'm just going to kind of add some 1s there so that when we're doing this, it makes it a little easier. So I have 1 magnesium on the left side and 2 oxygens, okay? And remember, this arrow kind of splits in our reactions in half, and I have 1 magnesium here and 1 oxygen over there. So I see that I have 1 magnesium on both sides, which makes it even, but I only have 1 oxygen on the right side, whereas I have 2 on the left side, and so that would be unbalanced, okay? So we want to start on the side that has the smallest amount. And I can put any number here. I could put 24, I could put 3, but we really want to pick a number that will make them equal. So I ask myself, what number times my subscript 1 right here will make it equal to the other side, which is 2. And I say, well, a 2 would do that. 2 times my 1 oxygen changes this to 2. But this magnesium and oxygen are bonded together. So what you do to one, you have to do to the other. So 2 times my 1 magnesium is also 2. And so I say, okay, my oxygens are balanced now, but my magnesiums are no longer balanced. So I pick the side that has the lowest amount, and that would be the left side or the reactants. And I say, okay, my magnesium's here. What times 1 will give me my answer to be 2? I say 2 times 1 gives me 2. And now I can see that they're equal on both sides, and I'm complete. Now, you leave the blank in front of oxygen. Essentially, there's an invisible 1 there. Remember, chemists are lazy. We don't write 1s. But if it makes you feel better, you can write the 1 there to fill in your blank. Okay, so let's go down to some of these. Let's work with this last one here. Okay, this is hydrogen peroxide. We're gonna do this one. Hydrogen peroxide, when it decomposes, produces water and oxygen gas. You may have seen this in the elephant toothpaste demo that we did at the beginning of the year. And if you didn't see that, just search that in YouTube, and you'll see some pretty cool videos. My favorite is the one on Jimmy Fallon. But let's go ahead and talk about this. So we split it up. So on the left side, okay, I have 2 hydrogens and 2 oxygens. And on the right side, I have 2 hydrogens. And here's where it's tricky. I have an oxygen there, but I have 2 there. So I have 1 plus 2 gives me a total of 3 oxygens. And so anytime we have a split oxygen like that, you're always going to want to make them into an even number, generally. But I always recommend solving for oxygen last. Just makes life a lot easier. So in order to make this an even number, we have to pick the side that is not even. This has 2, that only has 1. If you put a 2 in front of something, it automatically makes it an even number. So 2 times my 1 oxygen is 2, plus these other 2 over here changes my answer to 4. But my hydrogen is also affected, so 2 times my 2 hydrogens is 4. And so now I need to fix my left side, and if I put a 2 here, it fixes both of them. It multiplies both by 4, and now I'm balanced. And so the trick to this one is realizing how to make that even with those split oxygens. Okay.